Hello, thank you very much for being here. I will be talking about developing secure web applications, and my talk will be about writing the code, taking into account all the vulnerabilities the web applications are exposed to. I will not be talking about other issues related with the security of our servers, with logging, monitoring, and backups. So let me first introduce myself. I work in a company called Faber. We are based in the north of Spain, in Bilbao. We have been developing web applications since 2002. It's a long time developing web applications, and we have been working with different frameworks. We started with OpenACS, then we were early adopters of Ruby on Rails, and since 2018, we are working also with Phoenix. Depending on the case, we are using the framework that we think fits better the use case. You can contact me if you want to talk about security or about web development. Before I start speaking about security, I want to make a short disclaimer. I am not a security expert. What I have a lot of experience with is writing a web application. So I use the knowledge of the security experts applied in the real life day-to-day programming. This talk is highly inspired by this book called Grokking Web Application Security. It's like a very good overview of all of the vulnerabilities the web applications are exposed to, with a very clear explanation written for software developers. It's framework agnostic, so it doesn't matter what framework you are using. It's very, very interesting read. And let me start with a quote from this book, which says that after all the work you put into building your web application, someone will immediately come along to kick the tires and scratch the paintwork when it is published. And I think that everybody who has a public web applications knows that this is the case. And we can do anything about it. If you put your application on internet and it's publicly available, then anybody can make any request to your application. If you look at your logs, you can see requests like this that obviously are not supposed to be made, but they come, so we have to be prepared. We have to be prepared for them. The web application, by the way they are used, are exposed to a lot of threats. We have browser vulnerabilities, session vulnerabilities, payload vulnerabilities, injection vulnerabilities, authentication and authorization vulnerabilities. It is a lot of threats that we have to take into account during our development process and also once the application is published online. So we will consider application secure if it can stand up to all of these attacks that it is exposed to. It's a lot of information. The security is a very big subject, and 20 minutes is a very short time. So I have just selected what I think is the basic one that everybody have to know if he works on web applications. And I will go like very fast over it because nothing that I will say will be new. It's like a refreshment that we have to have some from time to time to know what is out there. So I will talk about browser vulnerabilities, session vulnerabilities, payload vulnerabilities, a little bit about injection vulnerabilities. There is a document developed by the Erlang Ecosystem Foundation's Security Working Group about web application security best practices. It's a detailed explanation of the vulnerabilities with a lot of references. So if you want to go deeper in the subject, you can take a look at this document. So let's start with the browser vulnerabilities. As I suppose if you have worked in web application development already know, there is the cross-site scripting and the cross-site request forgery. So there is a very interesting Phoenix application which is intentionally vulnerable to this kind of vulnerabilities that you can download and play a little bit to check how these vulnerabilities can be exploited and also how they can be solved. So if you have time, you can download it and play a little bit with it. There is also like a documentation which guides you step by step in all the process in detecting the vulnerability and then finding the solution. So let's start with the cross-site scripting. The cross-site scripting occurs when attacker-controlled JavaScript is executed in the browsing session of the victim. Like the very basic example of this is if you give the user opportunity to introduce some text and then he puts some JavaScript inside the text, then when you display the text, your browser will execute the JavaScript. So that is what the browser does. It receives some HTML, some JavaScript, some CSS, and then renders it. So if there is JavaScript in the source, the browser will execute it. So this JavaScript will be executed in the session of any of the users that access the page, and this one is very, very naive, but if you can execute JavaScript in the session of the user, you can do like bad things with it. If you are using Phoenix to develop your web applications, we are safe because Phoenix by default escapes all of these characters. So if we just show the input of the user, the JavaScript will be escaped and will be shown as text. It's very important to take into account that the user input not always comes like a part of the parameters submitted by a form. It also can come from the GET request. For example, if you have a search field and you put some input there and then you show to the user the result for the search, showing what they have included like a search parameter, the user can send anything. You cannot control this. So if the user sends like, some JavaScript encoded in the value of the parameter, this JavaScript will also be executed. So nobody can prevent a malicious user from crafting this kind of link and put it somewhere, and then the user clicks, and this JavaScript is executed in their session. So when working with user input, it's very important to be very careful when using the raw function. Only use it when you know what you are doing. And also, if you send HTML directly to the con with the HTML function, all this protection that Phoenix gives us when we show HTML in the templates is not applied. So the user content will not be escaped. In this case, we have to take care about this. So the way to protect against this kind of attacks is to interpolate always untrusted content in HTML. And also, in addition to this measure that we can take like part of our code, we can add the content security policy request header, and which will prevent the browser from executing JavaScript depending on the content of this header. It's easy to add it like a parameter to the put secure browser headers. There are some details that you have to take into account when doing so. There is a very good article explaining these details and giving the solution that will make your web application work as expected with different browsers. There are two more XSS attacks that are not directly related to the code we write with Elixir, but I think it's important to talk a little bit about them. The one is the so-called DOM-based XSS, where the part of the JavaScript is in the URA fragment of the URL, which is the part after the sharp sign. So the browser, when makes the request, only sends the first part of the request to the server. Then when the browser receives the response, shows the page, and then executes what is sent as the URI fragment. So if you have like a kind of single page application where you manipulate from your source, from your code in JavaScript, the URL of the page, you also have to take into account that this URL can be manipulated and do not show it as it is inside your HTML. Also, there is the cross-site script inclusion vulnerability, which is related with the fact that our JavaScript, if we can access it from our site, it can be included in any other site too. So we have to take care about the content of the JavaScript files that is created dynamically. All sensitive data that is related to the user that is accessing the page at the moment have to be loaded asynchronously, not included as part of the JavaScript. And also, the other way to work with this information is including it as part of the HTML, and then JavaScript access it from the HTML. It's not included in the JavaScript itself. Also, you can use the cross-origin resource policy header to tell the browser where it can load JavaScript from. It's like additional security measure, but if there are different steps of security, like implementing security in depth, we are more secure. The next browser vulnerability is related with the cross-site request forgery. I think it's not necessary to explain it, because if you are working with web applications, you already know about it. If you use Phoenix for your web applications, it's already taken into account. If you use the Phoenix helpers to generate the forms and then use the Protect from Forgery plug, everything will work as expected. And if there comes a request with from other side where the cross-site request forgery token is not correct, just the response will be an error. So just use it, and that's it. Take into account that the GET requests are not protected by this mechanism. So you have to be sure that the GET requests should not have any side effect, because this CSRF protection is not applied to them. There is an article with a detailed explanation and an example of this kind of vulnerability. It's very interesting. It's just to take a look at it if you want to see how this can be exploited. So here I stop with the browser vulnerabilities and go to the session vulnerabilities. We have to use sessions because we are using HTTP to connect the browser and the server, and the HTTP is a stateless protocol. So we have to use some mechanism to know who is accessing our web. And these mechanisms are the cookies. So when our application receives a request, in the response, have to be included a set cookie key header with the special configuration which instructs the browser to send us this cookie with every request that it makes afterwards. So we know who is accessing our page and can make the proper decision of what to show or not show to them. So as the session is something that goes forward and backward, there are two kinds of session vulnerabilities: the session hijacking and the session fixation. The session hijacking is when the attacker steals the user identity while they are browsing our application. So the attacker can make actions as if it was that user. The session cookie can be accessed directly from a browser. You can use your inspector to check the cookies that every website has set on the browser. You can also see the content. And on the other side, in our application, we can access the session data that was included in the cookie using the get session function. This is what the default Phoenix session includes. This is the CSRF token, the user token that we use to identify the user, and also the LiveSocket ID. I will have no time to talk about WebSockets, but they are already considered with in Phoenix. So you can configure the parameters of the set cookie header that is sent as part of the response from the endpoint.ex file. By default, Phoenix configures it to use the cookie like a session store. You can add signings out to make sure that the cookie content is encrypted. So even if we can see it from the browser, we cannot access the content itself. Also, you can set the same site value and the secure. With this configuration, the set cookie header that will be sent will assure the integrity of the session, because the session is signed and also is encrypted. The HTTP only parameter says to the browser that this cookie cannot be accessed from the client side. It has to be sent only with the HTTP request. The secure parameter says that the cookie have to be sent only over secure connection, and then the same site value instructs the browser to not send the cookie with requests that are not GET. So we are quite secure with this default configuration. If you have to change something in this configuration, make sure that you know what the consequences are. There is another kind of session vulnerability, which is called session fixation, which is like the opposite of the session hijacking. It's when the attacker prepares a session and then makes the user use this session instead of their own. So, for example, an attacker can prepare a session, trick a user to access our application with this session, and then when the session logs in and some user-specific information is saved in the session, the attacker has access to this information. The way to protect our users from this kind of vulnerability is to have a mechanism to invalidate the cookie when there is some change in the user state. For example, when the user logs in or logs out, the session has to change, so it cannot be used again. Working with sessions is hard. There are a lot of details that have to be taken into account, so the best we can do is use some solution that is already tested and we know that it works. For Phoenix applications, we can use the Phoenix genout task to generate a flexible authentication system, which will take care about invalidating session keys, closing socket connections, also when there is a change in the user status. So we can use this. If you change the default implementation, be sure that you are not introducing some additional vulnerability. So let me talk now a little bit about the payload vulnerabilities. What we have seen up to now are exploits that try to access user data, but there are other type of attacks that try to access the server where the application is installed on and use this server for their purposes. So here include the remote code execution attacks, the file upload vulnerabilities, path traversal, and mass assignment. I have a very short time, so I will go very fast over it. The remote code execution is something that can be exploited in Elixir. There is an article about it if you want to see an example about this exploit. In summary, there is a function binary to term which you do not have to use with user input, and also you have to make sure that your dependencies do not use this function. There is an alternative you can use if you have to. File uploads. We always have to add some file upload in our applications. The important thing here is to take care about all the file data that we have and do not trust what the user says. It's a very good idea to rename always the files and not use the name provided by the user. If you have to keep the relation, just save it, for example, in the database. So validate maximum file size in order to prevent mass attacks that will fill all the space that you have available. Set constraints on the file names. the file type, check the file type by yourself. Do not trust what the user says you. Rename uploaded files, and also store the uploaded files somewhere separated from the rest of your application. Path reversal is when the user tries to access files outside of our web root folder. It's very common attack. It's easy to make like a mistake to introduce it, because if you generate links and you are sure that they are correct, we then try to send directly what the link value gives to our controller, but you know that we cannot control the request that we receive, so we can receive requests of any type. In this case, if you do this way, we are vulnerable, because the attacker can access a file that we have in our root folder. So the way to protect against back reversal is to make sure that the user input is not the full name of it's not the full path of the file. There is some part that we put there, so we are sure that we are getting the files from where they belong to. We have to validate always the user input. The last thing is the mass assignment, but I don't have enough time. If you want to go out and take a coffee, you're free to go. Just a few comments about it. I suppose that everybody have heard about this vulnerability. It's related with the fact that if in our change set, all the attributes that we set there can be updated if we use this change set. For example, we have a change set with name and username. Then we define a function in our context and use this function to create users. Now, if the user sets user params that are not in the change set, they are ignored. But if we add some parameter that we add for our internal usage, but is part of the same change set, then if the user input contains this parameter, it will be saved in our database. So the way to avoid this is to use different tag to change sets depending on the data that we want to change. There is a good example if you take a look at the accounts context that is generated by Phoenix Genout task. You can see that there are different change sets for the different data that the user can change. So the last one are the injection vulnerabilities. Ecto is make it really difficult to introduce these vulnerabilities. So if you use it as intended, you are safe. So this is the last one. One more thing I want to show, I want to talk about is the stricto atom function. There is a limited number of atoms that we can generate in Elixir, so you have to be very careful and not using this function with user-provided data, because if your web is like a victim of denial of service attack, which sends a lot of different user input, and you use this function, you will exhaust all of the space that we have about it. What we can do? Use automated tools to check for the known vulnerabilities, in addition to taking them into account while you are developing your applications. Several, I suppose you know it, it's like a static code checker. It will show you the vulnerabilities it finds, and you can make the changes necessary to prevent them. There is a talk from the author of Sobelo. It's very interesting. If you have time, just take a watch of it. Mixaudit is a library that provides a lake task to find dependencies that have known vulnerabilities. So, very short. Use the defaults. Use Ecto for your database. Always validate user input. Do not trust the user input, because we don't know who sends the request. Use automated tools in addition to your coding practices. So this is the way to have applications that stand up of the attacks. I would like to finish with a quote from this document of the OWASP. There is no guarantee that the code is security bug free, and that's okay. The only way of not introducing security is to not code at all. So we accept that, and we're trying to prevent as many security issues as possible. Thank you very much. I'm sorry for the late. Here you have all of the references that I have sparkled in my talk.